The next common term is motion in physics. It is the phenomenon of change in position of an object is called the motion of that object. So what is motion? It is change in position of an object. In which of the following examples can you sense motion? And how will you explain the presence and absence of motion? The four examples are the flight of a bird, a stationary train, leaves flying through air, a stone lying on a hill. Amongst the given examples, motions that can be sensed by a stationary observer are the flight of a bird and leaves flying through air. A body is said to be in motion if it changes its position with respect to its surroundings. We can say that a body is either in motion or at rest. When we say that a body is at rest, it does not change its position with respect to its surroundings, and that indicates absence of motion. So this means a stationary train and a stone lying on a hill, they both indicate absence of motion. Think about it. You are traveling in a bus. Is the person sitting next to you in motion? No. The person sitting next to me is not in motion. Since even I feel that the person is not changing its position. Next question. What do you take into consideration to decide if an object is moving or not? Now, motion is a relative concept. An object is moving or not. It is decided on the basis of whether it changes its position with respect to its surrounding or not. When an object changes its position with respect to its surroundings, then it is said to be in motion. So, when I am sitting in bus and the person is sitting next to me, so in my surrounding, the person sitting next to me is not in motion. So, motion is a relative concept. The next terms are displacement and distance. Measure the distance between points A and B in different ways as shown in the figure. Now measure the distance along the dotted line. Which distance is correct according to you and why? So what I have done here is I have given some other points x, o, y. So you can measure distance on the path AXB, on the path AYB, and on the path AOB. The three lengths measured will have different values. Distance measured along straight line AOB is most appropriate. This is because there can be infinite paths to connect points A to point B. Straight line path is conventionally accepted as a standard in such case. Another thing that we have to consider is while measuring curved lengths such as AXB or the length with loops such as AYB is likely to be more than the error that may occur while measuring the linear distance along AOB. Let us take up another example to understand distance and displacement. Sheetal first went to her friend Sangita's house on her way to school. Prashant went straight from home to school. Both are walking with the same speed. Who will take less time to reach the school and why? In the above example, is there a difference between actual distance and distance traveled? So let us take a first question. Who will take less time to reach the school and why? You can see here Prashant has covered the distance only 1300 meter. But Sheetal, she has covered the distance 500 meter to Sangita's house and further 1200 meter to school. So her total distance becomes 500 plus 1200, that is 1700. And as Prashant and Sheetal both are walking with same speed, time they will take to reach the school will be directly proportional to the distance they are traveling through. Since Sheetal covers more distance than Prashant, she will require more time to reach the school. Second question. In the above example, is there a difference between actual distance and the distance traveled? What is it? Immediate answer is yes. Of course, there is a difference between the actual distance and the distance traveled. The actual distance between school and the house along the straight line is 1300 meter, as we can see here. While the distance traveled by going via Sangita's house and thus by changing the direction of the motion is 500 plus 1200, that is 1700 meter. So the distance traveled in this case is greater than the actual distance. Use your brain power. Every morning, Swarali walks around the edge of a circular field having a radius of 100 meter. As shown in the figure 1.2, if she starts from the point A and takes one round, how much distance has she walked and what is her displacement? Now Swarali is walking on a circular path. So let us find her distance. As the distance walked by Swarali is on a circular path, so we will have to find out the circumference of the circle. So the formula to find the circumference of the circle is 2 pi r. And it is, value of pi is 3.142. R is radius, which is given here 100. So the product comes out to 628.4 meter. This is the distance walked by Swarali. Now what about her displacement? As her starting point and finishing point is same, she returns back to initial point. Her displacement is 0. Let us take up one more example. If a car starting from point P goes to point Q and then returns to the point P, how much distance has it traveled and what is its displacement? Distance traveled by the car from P to Q is 360 meters and back from Q to P is again 360. So the total distance is 360 plus 360 meters, that is 720 meters. This is the distance traveled by car. Now what about the displacement? Since the car starting point and finishing point is same, it starts and comes back to its original point. So the displacement is 0. Okay, so this helps us in understanding the concept of a few more terms: motion, how it is a relative concept, and the two terms distance and displacement. Okay, children? So go through all these terms, and later on we'll go through further even more terms to move ahead. Thank you.